So welcome back, everybody. So in a few minutes, we will have a new session about enriching and validating cultural heritage metadata. So the moderator will be the coordinator of the project, Eirini Kaldeli. And we will have two other speakers, Henk Vanstappen from Datable in Belgium, and Marco Rendina from the European Fashion Heritage Association. So Henk and Marco, if you can come here. And sorry, we have just to check the access, the online access. Yeah. So in this session will be technically oriented, and you will have the chance to learn about the methodology, the enrichment methodology that we followed in this project, and learn a little bit more about the tools, the AI tools and digital tools we used for enrichment and for validation. And at the end of this session, you will also be invited to contribute to an online campaign where you will be asked to evaluate the results of an automated tool that was applied on Mobilier National images in order to detect colors, the dominant colors in the pictures. So you will be asked to say whether these colors were correct or not. Yes. Great. Next. So. Yeah. Great. So I will start with a presentation in which I will try to describe the overall methodology that we followed, with an emphasis on the semantic analysis and semantic linking approach. Then Henk from Datable will proceed with a presentation about the content analysis tools that were used and the enrichments we got from these tools and crafted. And Marco will present the results of the validation campaigns we organized in the framework of Crafted. And then at the end of this session, as I said, we will have a hands-on campaign. So in the Crafted project, we took crafts heritage as a case study in order to implement, test, and validate in practice a methodology that combines artificial with human intelligence. And the main objective of this methodology is to balance a trade-off between human manual annotations and automatic annotations. So manual annotations, manual enrichments is a very time-consuming, resource-consuming task, and it is also a mundane task, especially if we consider the annotation of thousands or tens of thousands or hundreds of thousands of items. Artificial intelligence tools can highly contribute to automating the enrichment process. However, at the same time, they suffer from low accuracy in many cases, and they cannot be trusted blindly. So therefore, in Crafted, we applied artificial intelligence tools, and then we asked humans to validate a sample of the annotations produced automatically in order to decide which were of sufficient quality for publication, for display on your panel. So of course, enrichments can come in many forms, and one can distinguish them based, for example, on the type, on the source data that are to be analyzed. Are we analyzing text, textual metadata, images, video, audio? What is the objective of the enrichment? What kind of information are we trying to extract? Are we, for example, is it important to be able to search images by color? Or is it, do we want to identify objects on images? Or do we want to produce automatic translations, for example, of text? And of course, then depending on the content that is analyzed and the objective of the enrichments are also represented in different ways. Okay, are represented in different ways. For example, they may correspond to URIs that are embedded in the metadata. They may correspond to subtitles that accompany a video, or a transcribed text that is displayed along with an image of a handwritten of a historical manuscript, for example. So in Crafted, we considered the types of enrichments that are indicated in bold in the slide. So we analyzed textual metadata, we analyzed images for color detection, object detection, and we also performed optical character recognition. And we also applied speech to text. In the rest of my presentation, I will delve a little bit deeper about the part concerning semantic linking. So the analysis of text with the aim to augment to match, let's say, to identify entities and concepts in text and to match them with URIs from linked open data sets and vocabularies, such as Wikidata or domain-specific vocabularies, such as the fashion vocabulary or vocabularies that were created in the framework of the Crafted project. Then these URIs are embedded in the original metadata, as we will see. So why is this important, semantic linking? So the URIs allow us to adopt a common terminology and have a common understanding about items that may be described in different ways. So, for example, let's assume that the metadata indicate as the creator of an item, John Ellis. This may be written in many forms. And also one has to take into consideration the cases, the tenses, the different forms of language that John Ellis may be referred to. Also, metadata may come in different languages. They may be either in descriptions or in more specific fields, such as the DC spatial, the metadata field that captures spatial information about the item. To add yet another level of complexity, one has to deal with the problem of disambiguation, because there are many John Ellises out there, and it is difficult to deduct which John Ellis is the one related to the object at hand. For example, there is a John Ellis who is a guitarist and songwriter, and there is a John Ellis who is a theologian and a clergyman. And this is a very difficult problem. So based on context, and actually the very limited context that most of the times metadata provide, to infer which is the right John Ellis, should we link, so to which Wikidata URI we should link to. And in the end, the URIs point to additional data, such as translated labels or broader labels retrieved from the vocabulary that we are considering. And this advances the discoverability of the item, supporting multilingual search and display, and also contextualizes the item. So for example, if an item is enriched with a URI linking to the term polythrona in Greek, this example is from a vocabulary that was developed by the National Greek Aggregator in the framework of Crafted, with the objective to describe, to represent terms related to Greek traditional crafts heritage. Then by having these links, one would immediately understand that polythrona means armchair, and would also gain access to the broader concepts to which armchair belongs to, and be able to read it also in their own language, if also more languages are supported by the vocabulary. So this is the overall architecture that materialized the methodology that we followed in this project. So the first step is to import the new records representing cultural heritage objects into the MINT data aggregation platform. And then these are mapped to a common European, to a common format, namely the Europeana data model that also Maria Teresa mentioned in her presentation. And then on these records, the automatic enrichment tools are applied. Also speaking to external, communicating with external services, for example, to retrieve the content of the respective items, or to communicate with Wikidata and other external services. So in Crafted, we used SAGE, a tool developed by the National Technical University of Athens for the semantic analysis of metadata records, and a suite of tools for content analysis, color detection, object detection, optical character recognition, and speech to text. And Henk in his presentation later on will provide more details about those tools. Then after the automatic annotations are produced, these are passed for validation to humans. A sample, a carefully selected sample of those annotations, because we are talking about thousands of annotations. And I will come back to this later about how important the sample selection is. Two main tools were used for validation purposes, as already Yalan mentioned. So the Crowd Heritage platform, which you will also have the opportunity today to play a little bit with, and the SAGE enrichment and validation platform. And then the feedback we received from humans is exploited to fine-tune the automatic enrichment, the setup of the automatic enrichment tools if needed, in order to derive better results, and then to apply appropriate filters before publishing the annotations to Europeana. So here I try to indicate the main steps, to describe the main steps that we followed during in the framework of this methodology. So the first steps is about analyzing the characteristics of the metadata and the content at hand. For example, do we have photographs in black and white, or do we have paintings? What is feasible to extract from what we have? What is relevant to extract? So do we want, for example, to support users who wish to search garments based on colors? So we specify our enrichment objectives, and then of course we map the metadata to the Europeana data model, and these specifications guide the setup of the appropriate workflow that makes use of the automatic enrichment tools that are relevant for each use case. Then, of course, human validation takes place on a carefully selected sample of the automatic annotations, and then the results of the human validations are analyzed, statistically analyzed, and relevant metrics are computed in order to establish appropriate thresholds for filtering. And if needed, to reapply an improved version of the automatic enrichment tools. Let me give a specific example. For example, let us assume that we have a collection with photographs of items with inscriptions. And these inscriptions contain useful information, for example, about creators, places, or have short descriptions of the depicted items. And at the same time, the metadata of these items is poor. They lack much of this information that one could find on the inscriptions of the items. Then it would be relevant to apply optical character recognition on the images and semantically analyze the results of the optical character recognition. For example, to link names and places with Wikidata and identify concepts from the fashion thesaurus, let's say. Then we perform a preliminary validation of the outputs of the OCR. Do they match what is depicted on the image? And then we also perform a more in-depth evaluation about the semantic linking results. Then we compute relevant metrics. What would be the relevant metrics in this case? They would be the word index error rate for the text, for the result of the OCR. And usually we use precision as a metric for the semantic annotators. And we would calculate the precision for different annotators that were used in order to find which produce better results. And then based on these results, we might also decide to fine-tune step 2. So the application of the automatic tools. For example, we might tweak the string matching rules or apply revise the language detection step and so on. And then we filter out, we apply the filters. It may be the case that, for example, all annotations produced by the fashion thesaurus, because this annotator produced very good results, are good, and we decide to publish them all, while the named entity recognition and disambiguation tool did not produce good results, and we decide not to publish them. So as I said, SAGE, which stands for Semantic Annotations and Generation of Enrichments, is a platform developed by the National Technical University of Athens, which we have used in the framework of Crafted as well as another project to analyze textual metadata as well as other text produced by content analysis tools in order to link strings with control terms from linked open data sets and thesauri. And SAGE offers several types of annotators, several subtools, let's say, that can be applied for semantic linking purposes. It communicates with the Wikidata endpoint, so it formulates appropriate queries for Wikidata. It allows users to upload their own domain-specific vocabularies and parameterize the setup of annotators, for example, by defining for dealing with different languages, applying appropriate lemmatization, string matching rules, use of taxonomies, and so on. And it is also interconnected with some pre-trained named entity recognition and disambiguation state-of-the-art tools. These tools are usually trained on Wikidata and other open corpora and link with Wikidata. SAGE also serves as a validation tool. It has an environment that allows users to visualize the annotations, the semantic links that were produced, and to validate them. So here on the left, you can see the text that was analyzed, the strings for which matches were found, and by hovering on each of the strings, you can see the annotation that was found for this string. And there you can accept or reject the respective annotation, and also users can also add their own annotations, their own URIs that were not detected by the automatic tool. Crowd Heritage is an online platform, again, developed by the National Technical University of Athens for organizing online crowdsourcing campaigns. As opposed to Sage, it is not metadata oriented, but rather item oriented. So usually users are asked to validate or enrich features that relate to the content of an item, as well as enrich its metadata, but on an item per item basis. But I will not go into more detail because Marco will cover the validation tools later on. So I would like to say a few more words about the sample selection. So the sample of the annotations that we decide to pass on to people to validate. The sample does not have to be large, but it has to be representative and to take into consideration multiple dimensions. So we have to ensure balance with respect to content characteristics. So both, for example, images with different colors have to be present in the sample. We have to ensure metadata field coverage, make sure that both short fields and longer fields are evaluated. Usually we prioritize the validation of annotations that have a high items impact, so that are relevant for many items. And also we ensure that both coverage with respect to confidence level. So in many cases, the automatic tools produce an automatic metric that plays a role, that indicates how confident the automatic tool was about the annotation it produced. So we would like to include in the sample, ask users to validate both annotations for which the tool was very confident that they were good, as well as tools with lower scores or medium scores. As I have already mentioned, usually we use precision as a metric. Precision indicates, for example, in the case of color detection, how many of the colors that the automatic tool identified were correct among all colors that the tool identified. Recall is another indicator that we also use. So recall is about the correct annotations among all desired relevant outcomes. So it would also take into consideration the colors that the tool was not able to detect. For speech to text and OCR, we used word index error rate. We also investigated the correlation between human judgment and the automatic confidence scores in cases it is available, because the automatic confidence score could in some cases be used as a threshold, as a filter for publishing what good quality annotations to Europeana. And all these metrics were applied and calculated at different levels of granularity, depending on the use case at hand, at the field level, at the annotator level, or per color, or at the dataset provider level, and so on. Then the filtering took place. Usually we trusted humans in most cases, or were a little bit stricter and applied majority rules about what humans said, if we were able to have more than one judgments per case. And we also included the annotations added manually by users and probably also peer-reviewed by other humans. However, this only regards the sample that was reviewed. The important thing is to be able to generalize and decide about what to do with the annotations that were not reviewed by humans, which is the vast majority of the annotations, because we are talking about hundreds of thousands of annotations. So for the non-reviewed annotations, we use the metrics that were relevant in each case. In most cases, we usually set a threshold for precision between 17 and 80%. And we applied also some other kinds of filtering. I will not go into more technical details about this. But this is how an EDM record enriched with automatic annotations looks like in the end. So there is an extension of the EDM that accommodates for the representation of automatic annotations. So for example, in the case a match was found for creator John Ellis, the respective URI would be added in the metadata. The confidence level would be indicated if available, and the was generated by parameter would indicate whether this annotation was produced by a software agent or a human. So in total, in the crafted project, and these numbers are not the final ones because we are still enriching some data sets that are still coming in. We enriched with automatic annotations more than 127,000 items and produced like almost 500,000 URIs annotations. So if we take a closer look at how the different semantic annotators performed, there was a huge variation between different data sets for the same annotation, and also the metadata field on which these annotators were applied also had a great impact, made a difference on the results. The general conclusion probably that we can draw is that the more domain specific the vocabularies are, the better results we get, while more generic named entity recognition and disambiguation gives not very good results, especially when considering larger textual values. But let me share some lessons learned, some conclusions from this analysis. So one lesson that we learned is that shorter fields, and that's expected, usually lead to better results. Good quality domain-specific vocabularies usually led to very good results, also for long textual values, such as description and title and OCR outputs. While generic named entity recognition and disambiguation usually did not perform very well in long textual values, either because it gave rise to entities which were considered by human as being too generic. For example, if the string human is matched to the URI human on Wikidata, this is usually does not serve a meaningful, very meaningful, probably use case for the end user, and therefore were rejected by validators despite the fact of being correct. Or because of wrongly disambiguated entities, because as I said, this is a known, very difficult, open, also research problem. The attitude of the validator also affects how good the precision is. Some validators were very strict and only accepted terms that really matched with what they had in mind and were relevant to the use cases they had in mind, while others were more tolerant and accepted, let's say, generic terms such as fashion, for example. With respect to the fine-tuning, we applied to the types of fine-tuning we applied to the semantic annotators. In most cases, human feedback helped us to identify case-appropriate patterns for string matching, so regular expression kinds of appropriate regular expressions that would capture textual values that were in a format that was not captured in the first round. And we also restricted, in some cases, the annotator to a subset so that it considers only a subset of the data set based on the thesaurus, based on the vocabulary hierarchy. So to conclude, we think that this methodology that combines automatic enrichment with human validation has a great potential for scaling up the enrichment of cultural heritage related metadata in a cost-effective way. Surely automatic tools should not be trusted blindly, but we think that human evaluation on a carefully selected sample in the end allows us to achieve high precision end results. And for sure, there is no one-fit-all solution. It is very important to study the characteristics of the data sets and the objective of the enrichment in each case so as to adopt an appropriate workflow and combination of tools. So thank you. And yeah. I will give the floor to Henk now. Yeah. Questions first? Yeah, unless there are, yes, of course, questions. No?
Hi, so my name is Henk Vanstappen from Datable. I want to, as has been said before, introduce you to the content enrichment, so the image-based enrichment that we've done for the Crafted project. I want to start with this revolution from the 60s, which was the paper dress. If you bought 2 cans of Campbell soup, you could get this dress. So those were the good days. But I chose this picture, which is not in the Crafted collections, by the way, but I chose this picture because it has everything in it that I want to explain, which is the things that you could derive from an image, like this is a dress, this has some text on it, like Campbell's and soup, and the dress is red and white and some other colors. So these are the things that we could extract maybe from an image, and I will try to explain how we did it and what goes well and what goes not so well sometimes. So the first thing is object detection. For this we use the tool which is actually provided by Google. Which is like a very generic object detection tool. So you send it an image and it gives you back information about objects on the image. And it's found in this case 2 things, like the dress, which is good. It also found a person. It's not very certain that it's a person, like confidence score of like 25%. So Google says maybe it's a person, but probably not. And also in this case, we're interested in crafted, in fashion collections in this case. So we're not interested in people or in persons. We only care for the dress. So what we did actually was filtering out those objects that were not relevant, and also filtering out those objects recognized with a too low thresholds, so too low confidence level. So, but what we got, what was left then was, in this case, the dress, the fact that it was a dress. And the good thing about Google is the Google Vision tool is also that it gives us an ID of yet another database called Freebase. But with this ID, we can actually get identifier from Wikidata and also from Europeana Fashion Thesaurus. So we can get a resolvable URI, which we can then add to the metadata that we send to Europeana. So this is the first step. We didn't apply it very much in the Crafted project, mainly because most of the data we got has already had this kind of information, so it wasn't very useful to redo it. But we did it for a small collection of images from sound and vision. So where we could extract things like computers and crocodiles and data storage devices. So of course, we didn't use all of the information, but we could add some subject metadata to this image collection. Next step is color detection. And actually in color detection, we use also the results from object detection. So what we want to extract here is the colors red and white, but not the color black, which is actually the main color of this image. But we're not interested in that. We're only interested in the colors of the dress. So from the object detection process, we get the parameters, the coordinates of this dress. And in the next step then, we can use this information to remove the background. So we have a tool called GrabCut, which is actually a Python library, but doesn't matter, which is capable of removing backgrounds from the side of the picture. So you only have the actual object left. So we won't have black as a color for this image. And then the next step is actually to just reduce the number of colors, actually count the pixels and count their colors, and map all those colors to one of the colors of the fashion thesaurus, which is like, there's like 10 colors in it, I think. Yeah. So we derive from it the red and the white, which are the main colors. The tool also will have found some black, some yellow or beige color. But this also we remove because it's below the threshold of, like, say, 15%. And this again is then mapped to the URI. And this, of course, we apply to different collections, but mainly again from textile and fashion collection, because it's like relevant information. It wouldn't make sense to do this for an image of a cat. Or maybe it would have, but we haven't done it. And it works fairly well, actually. So, like, from these samples, most of the colors we extracted were quite good. We found out some things after the validation that, for example, there was an overrepresentation of gray. And then we found the cause. So the tool that we used was actually had a tendency to tag colors as gray while it wasn't gray. So, for example, the blue boots or the blue shoes you see in the middle, big chance that it would have said it was like gray, while it's a kind of grayish blue. So from this we learned, and we're already working on the next tool that won't have this problem. Then, so the third step we could do was finding text in the image. For this, again, we use the pre-trained model from Google. There are a lot of tools for OCR. So the classic OCR, in which you just give a document and it will give you back the text that you can edit then. But these classical OCR tools, they wouldn't work here because it's like an image of an object with some text in it. The good thing about the Google Vision text detector is that it actually can first find the text in an image and then only process it as with the classical OCR tools. Of course, as you can see, the result here is like Campbell's soup, 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 Campbell's soup, soup again. So it's not very interesting to show this to an end user, and so it needs some post-processing. So in this case, of course, obviously we will do some deduplication of all the words that we got. But then the next step would be to pass it on to the semantic analysis tools and to extract from this raw data the relevant concepts with the use of the relevant vocabularies. So this is very important. Like, you could do this, but very often it's not something that stands on itself. So we have to do a lot of post-processing. Some examples from the crafted project. So on the left, you'll see some prints from a print collection from the Prato Museum. And yeah, it's not visible what is written there, but it's like, it's not really, yeah, it's like printed text, but in like the scripts fonts, not the classical font. But actually the tool retrieved lots of text in it. You can read it on top. So it's found things like a date, Paris, chapeau en velours, what else, a robe, even the name of the producer of the object that is depicted and everything. So this really was very useful. Another thing we did was applying more or less the same process on videos. So actually what we did was we cut all the frames up and took for each second we took one frame, then deduplicated, and then again processed them as images And we found also there things like, in this case, the common magic lantern it reads. But this tool also provided very useful to extract data from like the credits in the beginning or the end of a video. So in case this is not available in the metadata yet, you could find names of actors or anything in this way. The fourth thing we did, which was, well, not really experimental, but we didn't use it a lot either, but I just want to show it to you, is the speech to text. So what we did was we extracted the audio from video files and then passed it to a text recognition engine. Here again, as with the OCR, you see that it creates lots of text. Sometimes the quality is very poor because the quality of the sound is very poor, or the speaker doesn't speak very clear. It really depends on it, but it can be very useful. But again, you would need a lot of post-processing here to make it really useful. But this post-processing could have been done with the semantic analysis tools. So this is what we apply to some of the videos from Open University and Sound and Vision Academy. This is a table with all the results we got. This is before validation, so if you compare it with the other numbers, it will be a bit more optimistic. But this is what we achieved. And this is my speech. Questions?
Yeah. Clearly, my fellow panelists have a very clear presentation since there are no questions. I wanted to, well, my name is Marco Rendina. I'm the Managing Director of the European Fashion Heritage Association. First thing I wanted to say is to thanks with admiration our interpreters. I found myself doing this kind of job with my parents, which when they meet my parents-in-law, which are from Greece and they are instead Italian, I have to do your job. And after 15 minutes, I get a headache. So I really admire you. And you are doing in simultaneous. I do it instead the offline that kind of way. Okay. So I'm going to tell you quite briefly, because I think most of the important things have been said, especially by Eirini. I'm going to talk to you about the validation campaigns that we were responsible to kind of organize as EFA. I think that as Eirini said, we shouldn't trust blindly automatic enrichment. So a human validation is needed. The ideal, in the ideal world would be perfect to validate every single enrichment. But of course, then it doesn't make any sense to have automatic enrichment if you have to then validate one by one all the final results. So what we did in this project was to select a representative sample of automatic enrichment and validate these to check the overall quality, but also to kind of, and I think this is quite important, and Eirini mentioned this, to kind of also assess the and align the quality of the self-assessment that the tools do of data, because you know these enrichment tools gave a score, a confidence score. And they assign this themselves. It's interesting. It was interesting to see how the score matches or do not match with the human perception of the quality, with the human score, basically. So I think that it's important to distinguish two kind of campaigns that we did. The crowdsourcing campaign and the niche sourcing campaign. Crowdsourcing campaign is a collaborative approach that involves obtaining contributions from a large group of people. Typically, we did it through an online platform that we will see later on. You will try, and in this case, you have a diverse crowd involved with no specific kind of skill. So you count more on the numbers than on the knowledge of these people, in a way. So of course you can imagine that this kind of campaigns can be applied in some specific context, not in any context, and we will see briefly where we apply that. The niche sourcing campaign, on the other hand, is a more targeted approach. We involve for the specific task we want to do, in this case the validation, we want professionals or individuals that are with a specialized expertise in a particular domain. So, for example, to evaluate the semantic enrichment that were made on the fashion collections, we asked it to expert in the fashion domain to evaluate the results of this automatic enrichment. The crowdsourcing approach was used for the color validation campaign. So as we have seen before, we extracted colors from images. Validating, let's say, a color and saying that the Campbell dress was red and white mainly doesn't require really a skill. You don't have to have studied a course of colors at university to assess what is red and what is white. Even if also there you can have some surprises in the sense that people perceive colors in different ways, but this is another story. So in this case, for the color validation, we used the crowd heritage platform. The crowd heritage platform has been shown before briefly, and you will use it. After my presentation, there will be a session in which you will try it out yourself. Here we organized for the color validation 3 campaigns, and basically we were using this tool in which user should just basically say, yes, this is the right color, or no, this is not the right color. And eventually, if the right color was not present, they could add the colors themselves. So it's a quite easy, quite fast approach. You can then browse through all the images and just say yes, no, or this is the color that is missing. As I said, we did the 3 crowdsourcing campaign with the 3 partners that were providing images on these: Museo del Tessuto di Prato, MoMU in Antwerp, and the Greek National Documentation Center. We have validated with this crowd. We were about 185 contributors, more than 5,000 images, and there were more than 12,000 annotations. Annotation, that means color, yes, no colors, and new colors added eventually. So this is a bit the scale of these 3 campaigns that we did. These were the crowdsourcing campaign. Then we had also the validation of the semantic enrichment via Sage that we saw briefly before. In this case, we used a niche sourcing approach. So we didn't open this up to any interested contributor, but we focused on engaging a few experts, usually internal to our organization, to validate the result of the semantic enrichment. You have seen the platform before briefly, so I will not say much, just to give you an idea of the work that has been done. Basically, the user, the validator, was presented on the left with the in highlight in red with the terms that were being identified and linked to a Wikidata entry. So the named entities basically. And on your right, you have actually the link to the open sources, Wikidata or the fashion thesaurus that were linked. And you could basically also in this case say, okay, this is right, or no, this is wrong. And eventually you could also add, if some reference was missing, you can add the actual name identity and its reference there, basically. So this is a bit more complex, you can imagine, right? It's not like saying, yes, this is red, this is white. It's a bit more, requires a bit more of also of knowledge about the domain, let's say, in this case, fashion. In this case, we had 7 organizations partnered in the project that set up these niche sourcing campaigns. Museo del Tessuto, MOMU, ACT, which is the Greek aggregator, Galliera, Uscreen, Mobilier National, and MUO. We had almost 30,000 annotations validated, and there were more than 200 new annotations, so new terms that have been added by humans. And we have a total of 11 experts that did this validation. So you can see it's a different kind of ballpark compared to the crowdsourcing, which we had almost 200 people involved. I think that this was briefly what we did for the validation campaign. I think that now would be interesting to try together. So I think that Eirini will briefly introduce how the heritage campaign tool works, and we will validate together online and here a data set from Mobilier National, right? Oh, Galliera, Mobilier National, right? Okay. Thank you very much.
I think you can see the tabs. I think it's a problem. So in this hands-on session, we would like to invite all of you who are either online or on site with a laptop, because this task will require you to connect to the Crowd Heritage platform. And I think the respective link is posted on the chat, yes, also for the online people. So there you will find on the top a campaign called Mobilier National Color Campaign. So here we have taken a selection of items from the Mobilier National collection, divided in 3 subsets, each consisting of about 200 items. So for the on-site people, I would say that starting from the left, we could focus the first people on annotating or reviewing the annotations regarding the first set. Then the next people should focus on the second set, and the third group there with laptops on the on the final set, part C. So first of all, you have to sign in to the okay, first of all, it says that the battery is very low. I'm just trying to prevent, like here. Yeah. So you will have to sign into the platform. I would have liked to show you how you can sign in. Unfortunately, because this is a foreign laptop, it was quite complicated to sign in with my Google account, and I did not want to sign in with my admin accounts. So, but I think it is very straightforward for you to sign in. If you do not already have an account, the easiest way to sign in is via your Google account. The other option is, of course, to register, which is also very easy by providing a username and a password. So after you sign in and you click on a set which you wish to review, first of all, you see the collections, the items belonging to these collections, which are mainly embroideries in this case. And by clicking on an item, on the left, you see the picture of it. And if you click on it, you can see it a larger scale so that you can identify in more detail the colors that are present here. So what we would like to ask you to do is to upvote or downvote the colors that have been identified by the automatic tool. The colors identified by the automatic tool are indicated by the CG computer generated tag. Well, if, for example, I add a color that was not found by the automatic algorithm, it is added in the list, but you can see that it was not computer generated. So besides upvoting or downvoting colors, automatic colors, we also ask you to upvote and downvote colors added by other participants of the campaign, so as to be sure that they did not make a mistake. I don't know how much time we have left for people to...
29 minutes.
Okay, so yes. Question. Yeah, for the online group, I would say then let's revise a strategy, because this is a good one. I would say that the on-site group, they focus on set A, and the online group focuses on set C, and then in the middle, when they see, people see that, okay, most items have been reviewed, they can see that by the votes added by others, they can move to the second set. Okay, so enjoy. Yes, then I think, yes, we can say that the time is off. People can continue, of course, after it. It's not that the campaign will close. Yeah. So I say that then we just leave directly after lunch, or should we? I don't know.
Maybe you go up the stage and you say lunch break.
Yes. Okay. Okay, then I'll leave you to your email.
Okay, so thank you, Eirini, Henk, and Marco for all those presentations. So online, we invite you to test and to validate and to play with the Crowd Heritage platform. And then after, we will all go for the lunch break. And so we come back together at 2 o'clock. So we will have an evaluation of the validation campaigns just after the lunch and the round table. So let's see you together. Let's see you later. Thank you.